Hello, and thank you for tuning in to the Flatirons Syndicate Motorsports Podcast. This show is brought to you by Flatirons Tuning, your source for any aftermarket or OEM Subaru parts. Be sure to check out our store at flatironstuning.com and stay tuned with Flatirons Tuning. Welcome back, everybody, to the Flatirons Syndicate Podcast. We're in the shop. We got DP and Dylan with us here today. And YouTube member Mike_44 had a great idea or request for a podcast, which is just for us to talk about rod bearing failure. What is it? What causes it? How can you avoid it? It's definitely something that's on people's minds. It comes up in modified Subarus or the Subaru world not infrequently. So it's a good suggestion for a topic, and so we're going to do that today. So I guess let's start by what is a rod bearing failure, or maybe just engine bearing failure, but more specifically a rod bearing.
Well, when the bearing is no longer seated where it needs to be,
right,
due to friction, heat, lack of lubrication, and things have moved to places they don't want to be, and things that are dependent upon those things are no longer able to perform as intended, and then there's sadness.
Yeah,
it's the short version.
Yes. So I guess maybe just a quick definition of a bearing, an engine bearing. They're shells. It's like two semicircles that go around the crank, and then they sit inside a component. So in the case of a rod bearing, those two shells are inside of the big end of a rod. In the case of a main bearing, they're inside the engine block itself. So you got basically a top and a bottom. They kind of snap into place, and that basically is the surface that basically is between, or that the oil creates a film between the crank and the part to let that part rotate around.
Yep.
So and the oil pressure is what creates that fluid bearing that the bearing rides on. So like one of the things to get out of the way up front is that there's not usually physical contact between the bearing and the crank. Like that's why it's a solid piece of metal. It's not like a bearing like you'd think of like in a skateboard wheel or something like that. It's a circular bearing.
Yeah, it's a journal bearing versus like a ball bearing.
Right.
It's meant to be a sleeve, not something that's actually physically rolling.
Right. And the reason that there's different sizes of these bearings is like there's different thicknesses of that shell, and it's because you have this gap between the crank and the part that the bearing snaps into, and so the bearing's job is really to take up space, so you have a very precise gap between the crank and the part. That's where the oil goes, and then that precise gap creates that fluid bearing.
Yes.
So that's what a bearing is.
Mm-hmm.
And I'll throw the picture up. I mean, they're not a whole lot to look at, but we'll throw something up on the screen so you can see what a bearing looks like.
It's elegant simplicity.
It's surprising how cheap they are too for such an important component in your motor. A really good set of bearings can typically cost, $100, $200 for like a really crazy set.
Yeah, they got some fancy ones now with special coatings on them to make them extra slippery, like just in the case that there is any kind of physical contact between the crank and the bearing. So yeah, there's a decent investment in there in the bearing, but it's a really it's a critical part. If you don't have them, well, man, you're gonna have problems.
Yeah. You'll know right away too.
Yeah.
It's not one of those things that like a wheel bearing where it starts groaning and you're like, oh well, that can wait a little bit. Like when an engine bearing goes,
yes,
lights are out.
So there's another term for bearing failure, which is a spun bearing. So what does that mean? Where does that term come from?
Great question. It's been a minute since I've actually used the term spun.
But typically, people kind of use it interchangeably with a car having rod knock, even if you don't necessarily have a spun bearing. But as far as I'm aware, the idea of a spun bearing is if you actually have a spun bearing, it's moving out of the seat that it is supposed to be in.
Exactly.
It has come
and
out.
It has made contact with the rod or the crank in a way it's not supposed to, and then twisted or spun out of position.
Yep.
Right.
I've seen some instances where the wear and the damage is so bad to the bearing that one of the shells gets captured. So instead of it being two hemispheres, like one actually rolls into the other, it moves out of place. You gotta try. You gotta work hard.
Yeah.
But that actually another terminology thing, knock. Like why does the term knock, or how does that term of knock have relevance to a bearing failure?
Well, I mean, the other thing to be clear about is, there is multiple types of knock. There's pre-detonation knock, which is like pinging from your car, igniting before it's supposed to spark. But there's also rod knock, which people typically, associate with a spun bearing or, that sort of bearing failure that Subarus are typical for.
And this is because, if you have a breakdown in basically this very precise volume that the oil goes into to create the journal bearing, and all of a sudden something is wrong, something's off, the pressure drops, what have you, then you can get that physical contact between the crank and the component. And in the case of a rod, because the rods are moving around, if that journal bearing isn't doing its job, then that rod moving around, you're going to have this physical contact where you actually hear a knock, where the rod actually hits basically the crank, and so then it's something like it's repetitive. It's like a ting 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 ting.
And it's high speed. I mean, you're talking, not just like ping ping, but you're talking 1,000 RPM.
It'd be
all of a sudden it's moving.
Tied to RPM.
Yeah.
So as RPM increases, the rate of the knocking noise would increase. RPMs drop, the knocking noise would decrease. But it's that you're hearing a physical contact that should not normally occur.
Yes.
Otherwise known as rod knock, or just generally speaking, knock.
Yes, knock knock, who's there? Engine failure.
Yes. So that's, I think, are there any other terms you think we should cover at the beginning? Any other bearing failure terms you think of?
Trying to think. Those are really the two most commonly used ones. I mean, I've heard of a wiped bearing, which is the same kind of idea where, it just wears contact and it smeared everything off of it. But
yeah, sometimes you can just see, it looks like a big swath of the bearing has been taken out. Yeah. Mm-hmm.
That's what happened. I've got a set of rods that I was given from a Subaru shop that he had wiped the bearings out. And they gave me the pieces to make business card holders by.
Nice. I guess not nice for the rods.
Poor customer, but I got a cool thing.
So there are 4 rods. There are 5 main bearings. So it's there's 4 rods, and so you basically got a bearing on either side, and then in between each rod. So that's how you get 5 main bearings, 4 rod bearings. If you have even one that's failed, is that a failure, or do they all have to fail?
If I've got one that's out, there's going to be contamination in the entire system, so you got to do it all.
Yeah, it only takes one.
Yeah.
That's the thing with Subarus is I've always typically heard that mains fail less than rods.
Yep.
It's always usually one of your rod bearings goes. If you don't catch it soon enough and kill the motor, you end up with rod bearing whatever sending material through and ruining any other thing that oil touches. Any other bearing, your turbo, journal, all of that is going to get cooked.
Yeah.
The longer you run it.
And you got to think about the oil flow through the engine. So the oil comes out of the pump and it goes in, and it will feed the main bearings first. And there's actually channels cut in the crank, and then the oil flows through the crank into the rods. So that's where the rod bearings would fail first, because they're getting the pressure second. So the main bearings might well be fine, but then the rods are getting the tail end of the oil feed, and usually by the time, at least through that path, the rod bearings are fed, then that's where the oil gets kind of sent out into the engine, collects in the pan, and back to the roller coaster through the oil pump and into the engine. Yeah. So that's rod bearing failure is much more common than a main bearing failure.
Mm-hmm.
And it only takes one. So let's talk about what happens when you have a bearing failure. What are the symptoms that you're looking for? What might you see or hear that would indicate that you have a bearing failure or specifically a rod bearing failure?
First, you'll probably hear it. You may hear your engine sound is going to be different if you haven't yet knocked it out of position, and it may still be where it is.
Even before you have a failure, symptoms might include high material wear. So if you send your oil off for analysis, going to Blackstone or one of those companies, you can actually look for the materials that are in the bearings.
Well, and they will look for it. That's one of the things they test for.
They'll test for it. So you can, check levels, and a lot of times they'll actually give you a recommendation if they see something like high molybdenum or whatever, a material in the bearing. That can be an early indicator even before you have real symptoms.
Yeah.
Like Nigel, one of our friends in the shop, he's super wary right now because of some material in his oil testing. So he's sending it off every oil change, trying to be super aware. and make sure he doesn't see those numbers change. So,
So this is one of the things you can use oil analysis for. In Nigel's case, he had sent off samples periodically, so he had a bit of a library of what the oil samples would come back as, and then they started to see a spike in certain materials that are present in the bearings, even though there's no other indicator that he has a bearing failure yet. And so that's one of the things that he's now concerned that he is now on a very short timeline before the symptoms are going to get worse. And then basically he's going to have to get in there and address it. One thing related to the symptoms, if you start to see indicators like that, does a rod bearing wearing in that way, is it ever something that would basically self-correct or get better?
No. That is not going to be, the self-healing engine is not a thing.
Right. Nor are there treatments that you can do with the motor in the car to correct that. There's no, rod bearing resealer or, whatever.
Right. You mean Blue Devil doesn't make one of those, they do a head gasket?
And really, any kind of additive, MOA, Lucas, whatever people recommend to you, that is just kind of a Band-Aid on an already, present issue that's not really going to help it. You might not hear the knocking in a motor that you run the additive with that was knocking without it, but that just means it's lubricating a little bit better, and you're hearing some slip versus some knock. So
So the thing to think about is this round space that the precise round space that the bearing creates around the crank. When you hear a knock, that is a physical contact with the crank and the bearing surface. And once you have that contact, the bearing is going to start to deform a little bit. What's interesting is in the right circumstances, and I think where there's photographic evidence of this, I'll have to dig it up if I can, but if you have detonation or pre-ignition, an explosive force that is pushing down on the piston top, it can actually drive the rod into the bearing. And what happens is you'll actually see a line indented in the bearing because that explosive force created a knock event where there's now an very small indentation in the bearing.
Possibly 2 knock events.
Or
the pre-detonation and the rod knock.
But even in that case, there's that physical contact that now is starting to affect the bearing and is starting to, which will then also impact that very precise volume that is supposed to be between the bearing and the crank. As you start to have more and more wear, what can happen, for the metal, the materials that come off the bearing itself, that's metal that for whatever reason is coming off of that bearing shell that is deforming that volume between the crank and the bearing, which changes the oil pressure, makes it more less consistent. So you're not going to have consistent pressure around the rotation, and that's where it's kind of it's a degrading condition. There's nothing you can do to put the material back short of taking the bearing out and replacing it. And once you get started down that path of this kind of wear occurring, it's the end is kind of always the end.
Yeah.
There's really no getting around it, unfortunately.
Yeah, and it is super important to be addressing it as quick as you can. I've heard of people, limping it along, adding additives, claiming, it's knocked for a few thousand miles, but it still runs, blah, 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 on all the sales pages, and it's...
Right.
If it's knocking, it's knocking. That is a failure. The motor needs to be rebuilt at some point to use.
So, what would be the motivation to go in there sooner rather than later to correct the problem?
Kind of like what I was talking about, where typically a rod bearing will fail early, and if you don't catch it or you let it run for a while or drive it home thinking you can limp it home, then you end up circulating material from the bearing, from anything else that's knocking. Your bearing fails, and all of a sudden your rod's starting to hit on the case of the motor, and it's scraping off material inside your crankcase now.
Right.
And all of that is getting circulated through your oiling system, and your oil filter can only do so much. In a serious failure circumstance like that, the filter is going to catch some and just start to bypass. And, we've gone all the way down the rabbit hole on those bypasses.
So, and even worse, so once you get the material into the pan of the engine, the flow of the oil is from the pan up the pickup, in through the pump, then into the filter, then into the engine. So if you have even really fine particles that the oil filter would catch, okay, well, let's say it catches 100%. It prevents those particles from getting into the engine through that path, but they're all going through the pump. And as soon as the pump, which also has a really tight tolerance rotor, that's where how it creates oil pressure. The georotor turning and pressurizing the oil, there's a really tight tolerance between these two interlocking rotors. You start throwing metal bits through there, and those start to wear. All of a sudden, that becomes less precise. The oil pump's ability to create the oil pressure for the engine changes or degrades to the point where now the pump can't supply sufficient pressure, which softens that bearing again, which promotes more contact with, degrading condition. Even worse. The other thing is that, you can have oil or particles that come off and get sent further down some other path that damage other things like the cams or your turbo, AVCS gears. Anything that the oil touches or that the oil drives or that is reliant on oil to function, once you have a bearing failure, usually those metal particles are going to be present everywhere that the oil is. Yep. Once you get to the point where it's glitter that you can actually see, it's probably everywhere, unfortunately. And that aggregate is then going to create wear on all of those surfaces. So the longer you wait to address a problem like that, where you're sending potentially this material through the engine, the more of those things that the oil touches on and interacts with would have to be replaced. So, and then
or at least cleaned and seriously refreshed. If you have a turbo on a motor that had a rod bearing failure, you're basically gambling if you're not having that cartridge rebuilt. It depending on the level of the failure and the amount of time you ran it, any components like that, you really want to consider either having reconditioned, having cleaned by someone who's very confident, in their ability to.
An experienced mechanic to go in and look at it and give you their assessment. This is okay, this is okay, this is not okay, or this is okay, this can be rebuilt, this can't be rebuilt. Because it's when you're putting something together, if there's damage that's occurred, you can the risk that you run putting an engine back together after that kind of a failure is, are you going to move any of this failure or contamination from the old engine into the new engine, which could significantly shorten or almost reduce to zero the life of the new engine.
Yeah, you'd hate to. Yeah, I always advise people on rebuilds, you'd hate to put one reused part on your brand new engine if you had a bearing failure and then have that be the thing that kills your new engine.
Yeah.
Because it's you just did it nice and did it twice effectively.
Yeah, and we've probably all seen it happen. It's happened with customers. This is one of the reasons why we recommend using new AVCS cam pulleys, because they have pockets where oil is stored, and you can have bearing material aggregate stored in those, and you can rebolt them, reuse them, and take out an engine very quickly. Reusing a turbo without cleaning it. We've reusing an oil pan that wasn't thoroughly cleaned, an oil cooler.
Yeah.
It's another one where there's little pockets and places for those oil and bearing material bits to hide, and then they come loose with the new build, and you basically cause damage right away.
Yep.
It adds up quickly, all those little pieces that you can replace, but the few $100s here and there is so much more worth it for the peace of mind of my new $2,100 short block, now I know all of the oiling components are safe to put on this, versus I'm going to reuse my cam gears, reuse my heads, reuse my oil cooler. No, don't do that.
Right.
The oil cooler is one of the few things that people say you can never reuse after a failure in a Subaru. There's virtually no way to clean all of those passages.
Just not to a degree that you can have confidence that there's no metal particles that are going to transfer from this used part into the new engine and then take it out. Yeah, it's every piece that you unbolt from the old engine and bolt onto the new engine, it's a roll of the dice. So, That's the biggest thing to keep in mind as you're going back through and rebuilding an engine after that kind of a failure.
And reasons to address it as early as possible.
Yep.
Like how we kind of led into all of this rabbit hole. You always want to address it. If you hear a knock, you have some like low oil pressure event, you see that oil light come on, even for a blip of a second, you should be, really, really thoroughly inspecting your oiling system. Even if you just come to the conclusion like, oh, my oil pressure sensor had a weird moment, or it was loose or something. Like,
let's talk about the oil pressure sensor in the car. So what I think this is the case with the FAs. I haven't double checked it, but I know with the EJs, they're all the oil lights are the same. What does that tell you? When does it turn on?
When there's nothing there.
It's not a level. It's a pressure gauge.
Yeah, it's when there's.
And it's like, I think it comes on at 16 psi.
Yeah, well, there's effectively like may as well be zero pressure.
Yeah. So when that comes on, especially if you're driving, especially if the engine's under load, like you now have low enough oil pressure that there's a very reasonable chance that damage has occurred.
Yeah.
So it's one of those, like, it doesn't mean that you're just low on oil. It means that the pressure in the engine is like below the absolute minimum possible okay range. Like you see that check or oil light come on, like you want to investigate it, like shut the engine down and investigate immediately.
Mm-hmm.
But it doesn't mean that the failure has occurred, but it's something like you should look into that like right away.
Right.
And turn the engine off fast.
Yeah. And because of how not very informative that gauge is, it really does make sense to consider adding in an oil pressure gauge and monitoring pressures on a motor, like on any kind of modified car. Like if you're seriously modifying your car and you're debating between a gauge and an intake or something, think about the gauges first just to get yourself ready for going down the road of modifications. And
with that oil pressure gauge, we've talked about that in other videos, but you need to put it on and drive with it for a bit so that you can get a sense of what the normal is.
Yep.
And then once you know what that normal is, then you can see abnormalities. And something to indicate like, okay, something is not working right, pressures are different than they should be, and then you get a sense of what all of that is.
Yeah. And I mean, that will give you an idea. If you are seeing low oil pressure, before that Subaru OEM light comes on, like, and that, that's exactly what I was saying. Like, it's worth thinking about doing that before you end up having this red light failure.
Right.
So let's talk about what causes are that could cause a wear condition or the precursor of rod knock, and then steps you can take to try and ensure that or minimize the chances that you're going to have that kind of a knock or that kind of wear.
Start with poor maintenance. I mean, if you don't change your oil regularly, turbocharged cars need regular maintenance. You need to put quality oil in.
Yep.
And I mean, like we've talked about, quality filter as well.
And level.
But the appropriate amount of oil, paramount. Yeah. Like, if you don't put, 4.5-ish quarts in, depending on your pan.
Right. and just make sure that the correct level of oil is present in the pan.
Yeah.
And this is where, especially as soon as you start modifying a car and or when you take it to the track or whatnot, you need to check your oil.
Yeah.
Use the dipstick. And check it and make sure that it's not running low, because a low oil level can be one of the precursors for a bearing failure.
Yeah, absolutely. If you're at the track, especially, when you're loading all the oil on one side or loading it on the other. Yep. Well, what's going on inside your crankcase could be a whole different story than the fun you're having.
Right. Why? Or let's talk about a couple of the ways that a low oil level, just low oil in the pan, can lead to some type of a bearing failure, or pressure difference at least in the engine.
Well, if you don't have enough oil in the pan to feed the entire system, and there's a lot going on in this guy. There's a whole lot of widgets that we don't have on this short block, but you all know, that engine's big and wide. It's got a lot of area it needs to feed, and it takes a lot of oil to feed that guy. So it may be one of those things where because your mains are fed first, and like we talked, rods are fed last.
Yeah.
If there's not enough by the time it gets to rods, to like an actual precise amount, because that's like perfectly spherical.
Well, even more than that, with a boxer engine, the heads sit on the sides, and the oil doesn't get right back to the pan immediately. So like you have an inline engine, the oil basically, the path is kind of straight down. So like it goes through the engine, it gets slung off, and then it drops straight into the case. With a boxer engine, you have a head on either side, so there's oil going through it, it's getting out to the valve covers, then it has to actually make its way back to the center of the block to fall back into the pan.
Mm-hmm.
So that's one of the key differences with a boxer engine, is that the return time for the oil to get back to the pan can be a little bit more, can be a little bit longer, because it just has a less direct path. It's not just a straight gravity-driven path back. It's kind of like it's a sloped. Yeah, think of it like draining like a paint pan or something that's at an angle.
It takes a minute.
It can take a second, and with the level in the pan, like you got to remember, like if you check the measure or you check the level in the pan when the engine is off, you turn the engine on, all of a sudden that engine is kind of a moving, living thing, because you're pulling oil out of the pan, you're sending it through the engine, then it's going to the kind of like its end location in the engine, valve covers, crankcase, whatever. Then it has to basically make its path back to the pan before it can go back up the pickup and into the pump. So the lower your oil level gets, the less total volume you have to be present in the engine that whole time. Like a worst case scenario would be kind of like what you're alluding to, DP, is that the level gets low enough, the pickup sucks enough of it out and it sends it through the engine, and then there's just enough of a lag to get the oil back to the pan that now the pickup it's not able to get a full charge of oil up the tube. Maybe there's more air pockets and stuff that get pulled in, which can then cause issues with inconsistent oiling pressure.
Yeah, and I mean, G-force just exacerbates that problem.
Yep.
So, like, you have a little bit of low oil, you're taking even an off-ramp on the highway kind of hard, or a clover on the highway, and all of a sudden you've got really low oil pressure, you've got air getting pulled into your pickup, and your rods and bearings are in danger.
Yes.
It only takes a couple of moments where you don't have sufficient oil flow to the pump and then into the engine to drop the pressure to the point where you can have potentially some kind of an issue. So that's why oil level is so important, but quality of oil, the changes of oil, the pump or the filter that you're using is all important. All of these are critical to make sure that you're getting a good flow of oil into the engine and maintaining a good level of oil pressure across all of the ports in the engine so that it can function.
Great. Another thing that you had alluded to already was pre-detonation, which actually both of you had talked about.
Yeah.
Run the right fuel, guys. Don't run pond water in your turbocharged car.
Yeah.
You will end up with a failure, whether you crack a piston or you bust it out the bottom end.
Yeah.
Run the right fuel, guys. Corn guys, the Lord's fuel like me, we're spoiled.
You have a far higher threshold for detonation. Probably you'll never get there, and that's a good place to be.
But if you're running fresh squeezed dinosaur,
you
got to make sure you run the right octane. Otherwise, you're going to end up in that same boat. So you're just going to drive that explosive event right down into that bearing.
Right.
And then it's going to say, ouch.
Yeah. And even if it blows by into your rings and not your bearing, then there's an oil consumption right there.
Yep.
Blow those rings up, and all of a sudden your car, it's eating a quart of oil every 1,000 miles.
Right. So then, to this, and also, I guess to start getting into things you can do to make sure that the car is running right, or to prevent this kind of failure, you want to make sure that the oil is in the engine, it's doing its job, it's getting into the pan. PCV system. You want to make sure that the PCV system, the positive crankcase ventilation system, is functioning properly. Again, we've done a lot of videos on this, but this is where, one, catch cans and air oil separators start to come in, potentially. If you see signs of oil moving through this ventilation system, you want to try and address that and control that, because again, you want the oil going back into the pan and running back through the engine. You don't want it moving out of the engine through the PCV system. So if you're the first thing to do is to check your oil, and then if you start to see the oil level dipping down, you want to try and figure out, okay, why is the oil going down? On a brand new Subaru with an EJ engine, FA engine, the consumption should be minimal to almost not negligible on the dipstick. To that level of measurement, you really should not be using any. if you start to see that increase, or if you're seeing more like something, a measurable amount of oil that's being lost in your engine, you want to try and kind of start doing some sleuthing around the engine to figure out, okay, well, why is that? Is it something that's just as simple as a leak? Are drips coming up from the bottom of the pan, or is it finding another path out of the engine, like through the PCV system and so forth? Because any of those paths out that don't go back to the pan, back through the engine, well, that's any one of those can cause a problem.
Most definitely. Like I was talking to you earlier about, my car is starting to consume a little bit, so I'm going to be checking it. To check the nozzle on the turbo, because it's like, well, maybe we have oil coming through. The bearing is, that seal has gone kaput.
Maybe it's possible, certainly possible.
And so maybe that's part of what I've got going on. Or, maybe I put a skosh too much in it when I just did the oil change, but it's one of those things that I'd rather, at least I hope it's that. It's just one of those where too much couldn't be too bad, but too much of a good thing is still a bad thing.
Yes, that is a delicate line.
Yes.
There, but start with making sure that there's a full oil pan.
Yeah.
And not overly full.
Right.
Mm-hmm. Yeah, and like steps beyond just the basic, have good oil, have the regular maintenance, keep your oil full, would be looking at stuff like upgraded pickups, baffles for your pan, or there's even like baffle plates for the bottom of the block in the crank. Yep. There's a lot of options as steps beyond what we've talked about as like the basics too. I'm sure we can kind of dig into some of the stuff.
We should touch on that a little bit. So for a stock car, again, it's just keeping the oil in the engine so that it can make that return path, get back into the pan, keep doing its job. Just grab another ticket on the roller coaster, send it through the engine. When you're talking about a track car, and I guess power-wise and pressure-wise, again, we've talked a lot about crankcase pressure and how it affects the PCV system. Proper PCV function is critical. If you want to keep the engine or the oil in the engine so it can do its job, you've got to make sure that you're not letting it get out through the PCV system. But then when you start tracking the car, like that, Dylan, to what you're just saying, that's where, okay, well now there's this new motion of the oil, which is it will move in the pan. As the car's going around corners, you're going to get more of sloshing. So that's where the baffling comes in. So like a windage tray, a baffle plate for the pan, a pan with actual like baffles like the Killer B, Super G pan, IAG pan, Roger Clark Motorsports Group N pans. They all have all this baffling to keep the engine in the pan, keep it around the pickup, and minimize any kind of movement of the oil in side loading. Because that's something that can happen in track cars for sure. Not as much on street cars, unless you're doing something that you really probably shouldn't be doing on the street. But, baffling is definitely something that is a preventative thing that, can absolutely help to keep the oil in the pan and keep it around the pickup where it needs to be.
Yeah.
And then the air oil separators are to like help grab that oil if it's going through the PCV system and send it back through and into the pan. We've talked enough about that in other videos. We won't dive too much into it here. But if you haven't watched those videos, go back to our channel or just go onto our homepage and search for, catch can, air oil separator, crankcase pressure, and you'll probably find a slew of videos, maybe more than you thought existed, with specific deep dives into those specific types of problems. So with all of that being said, is there anything else, any other measures that you can take to prevent a rod bearing failure or bearing failure? I'm trying to think if there's...
sometimes, in certain circumstances, changing your oil pump can. Like we always recommend thinking about stepping your oil pump size up if you're adding extra volume to your oiling system, like with external oil coolers and stuff like that. Sometimes people will step up to a slightly larger pump just to keep pressures the same. That's definitely one thing we've heard of from a lot of people, and we sell a lot of oil coolers and a lot of bigger pumps to people as well.
Yeah, and that's something where, like, if you're really getting serious about tracking the car, and you're putting on an external cooler to try and keep oil temps in to a minimum on track, which is actually temperature is something maybe we should even touch on here. But you want to ideally have some pressure data on both sides. before and after installing the cooler. Make sure that, okay, I'm putting on this cooler. This is going to keep the oil cooler. Make sure that you're not having any effect on the pressure that's getting in the engine by putting this aftermarket cooler on. Mm-hmm. Usually, and in most cases, when you have a company that's developed an oil cooler kit for your car, they've done the testing and they know that, like, okay, has all the right size fittings, the core size is right, everything is going to work correctly and give you the result that you need. Always good to double check that. Make sure that you're still getting good pressure on the opposite end of that cooler.
Yeah.
Let's talk temperature. Does temperature have a role to play in this?
Yes, I mean, as with most things, temperature can degrade, your oil, especially, if you're not, we go back to lubricity, like running the wrong viscosity oil or the wrong base oil number. Temperature's going to have a huge impact on what you're doing, because maybe you bought some oil that was like supposed to be, fine for all temperatures, but right now, it's unflammably hot here.
Yes.
There is no flannel life going on right now. I'm sorry, everybody. No. It's too dang hot. So if you have the wrong oil for the 100+ temperature range that we are at, you may see a problem in the bottom end that you don't even know is happening.
Right. So oil being a liquid, a fluid, as it gets hotter, it thins out. The viscosity changes, and the hotter it gets, the thinner it gets. So controlling your oil temperatures, like this would be one of the motivating factors to control your oil temperatures, or at least maintain a stable oil temperature, especially when you're on track. But when it's 100 degrees out, that can play a part. So like if you look, even just for a stock car, if you look in your owner's manual, there's usually going to be 2 different weights of oil, and the crossover point is what is the outside temperature.
Yep.
Because the manufacturers know that, like, when it's 100 degrees out, 110, like let's say you're in Phoenix or something, which that actually might be cool for Phoenix.
Yeah, they may be okay with that.
Yeah, they've been having a rough time with
They have flannels at 110.
Yeah.
They're like, it's cold.
But the OE manufacturer of the engine knows that at that temperature, the overall running temperature of the engine and everything like that is going to be so high. Well, maybe you need a heavier weight oil.
Yep.
So like if you're in a climate like we are here, where you have hot summers but really cold winters, just familiarize yourself with that owner's manual and make sure that, like, hey, if it's so hot this summer, like, and you're maybe running a 20 weight oil, maybe it recommends stepping up to a 30 weight. Or if your standard spec is a 30 weight oil, maybe it recommends a 40 weight if it's going to be over 100 for a prolonged period of time. That's especially something to consider if you're going to go to the track, because at the track, the temperatures on the track are going to be even hotter still. The engine temperature is definitely going to be hotter still. So you might actually want to step up to like a 40 weight instead of a 30 weight, something along those lines, if you know you're going to go to the track and it's going to be hot.
Yeah, I mean, we get customers that run even 50 weights or higher on the tracks, obviously, with, understanding how their motor works with that oil. They take that into consideration. It's not just like some stock car throws in a 1550 to go run a track day, but it is worth considering running a heavier oil like that, for sure.
And to be aware of how the temperature will affect oil viscosity. In one of the videos that we put out, when we actually took our Pikes Peak car to the track and tested it with the standalone, and we're logging oil pressure and oil temperature, we realized that once our oil temperatures got up above a certain point, which I think was 240 degrees, we actually started to see a little bit of a decline in overall pressure at max RPM, and it was tied to the temperature. So if we let the car sit and we were giving it more time between hot laps to keep the oil temperature in check, oil pressure was fine. Get the oil temp up, and then all of a sudden we're seeing these certain points where the oil pressure was not exactly where we wanted it to be, and that's even with a dry sump oiling system. So it just goes to show that, like, oil temperature can be very much related to oil pressure, and so it's something to be aware of, especially if you're tracking the car in hot weather or you're just driving your regular car in really hot weather. Yes.
Because, I mean, with the dry sump system in that circumstance, we 100% know it had oil flow. It's a dry sump. It has a 7-liter tank of oil it can draw from at any time.
It's way more liters than
that. But anyways, it's got a massive capacity of oil that it's drawing from, so it's not due to any kind of scavenging issue. It's just related to temp.
The oil and the pump, and that's it.
Yeah.
Right.
Pause.
Okay. Pause there.
I have a mustache hair that has been just doing this. And I've been like trying really hard not to tickle and sneeze. Oh. Warm. Up off of the warm couch of warmness.
I think I just need to wrap it up. If
Yeah.
for no other reason than like.
Did we go long?
I mean, we're pretty much over everything. We could talk about this for hours more, but there's just nothing really important to say.
I think that those are all of the high points.
Yeah. And one thing I was wondering if we were going to pull from was going to be we talked about the dry sump, which is like, again, the oiling system that fixes the PCV problem, all the things.
That'll be another.
Whoa. Oh, man. I don't know if I have you guys pick up or not.
Usually we've got somebody else that picks up.
I know, but since I'm with them now.
Oh.
Yeah, I do.
Okay.
Just that one?
So far. No,
Okay.
there might well be more later, but yeah.
All right, I'll come back later because I got to pick up over here anyway.
Oh,
so
yeah.
All right.
I'll come back later.
Thank you.
That must be the fluid damper for the one that walked away.
Oh, yeah.
I think I ordered 2.
Well.
One of them walked away again.
Yeah.
Okay, so I think just probably at this point, move to wrap it up?
Yeah.
Okay. Okay. Well, I think, man, as we're talking about it, I think we've hit all of the high points, all of the highs and the lows of it. So those are basically the best explanations we can give at this moment of what causes oil, rod bearing failure, bearing failure, and what you can do to spot it, address it, and then measures you can take to avoid it.
Right.
So I'd say if you guys watching, you have any other questions, definitely leave them in the comments below. If you think there's anything that we missed or we didn't cover, also leave it in the comments below, and maybe we'll come back and talk about those specific questions in another installment.
Yeah.
But yeah, definitely, it's something to be aware of. It's something good to have some familiarity with, good knowledge base of, and hopefully this has been helpful for you.
I hope so. If you do have questions like that, don't end up on our commentary, you can always hit us up in live chat or leave us a ticket, and we'll email us with what you've got going on.
Yeah, which is on flatironssyndicate.com. Or you can reach out to us through the Discord, which is basically a community of us and all of our customers. There's a link to the Discord in the description of this video as well. Both good places to reach out and ask questions.
Absolutely.
Yes.
Check your oil before it checks you.
That's right. That's right.
And while you're putting the right octane fuel in, check your oil at the gas station.
That's right. It never hurts to check. It never does. So, cool. Well, hopefully this was helpful. Thanks very much for watching. Thanks for your support as always. And until next time, stay tuned with Flatirons Tuning. Thanks everyone for tuning in to the Flatirons Syndicate Motorsports Podcast. Once again, we'd like to let you know that your support is what makes this show possible. Be sure to check out our online store at flatironstuning.com for any of your aftermarket or OEM Subaru parts needs. And as always, stay tuned with Flatirons Tuning.